Okay, this time, let me ask the following. Find the area of one petal of r equals to 5 sine 3 theta. Think about the following. And the interesting thing about this question is not only you need to know how to do the integral, you also need to know how to draw the graph. If you don't know how to draw the graph, then it's impossible to solve this. So let's try to draw the graph. First, when you plug in 0, you get sine of 0. So you start at the origin. Okay? And then as you increase theta, sine increases until this 3 theta is equal to what? When is sine maximum? When does it hit 1? Yes? Pi over 2. When it's pi over 2, it's maximum. So when theta is pi over 6, or 30 degrees, it reaches its maximum. So here's 30 degrees. And at 30 degrees, when you plug in pi over 6 to here, it gives you pi over 2, giving you 5 times 1. So you get 5 here. This length will be 5. And then after it reaches the peak, it comes down. It decreases, right? When does it hit 0 again? Pi. So when 3 theta becomes pi, in other words, when theta is equal to pi over 3, or 60 degrees, here's 30 degrees, and then this is 60 degrees. It's more like 40 degrees. Then it's going to be 0 again. So the graph looks like the following. It begins from 0. It's farthest from the origin when you're here, and comes back and hits the origin at this angle pi over 3. Good? All right. Then, if you are interested in what happens afterwards, it goes like that and goes like that to create three petal rows. I told you that this curve is named as 3 petal rows. And it completes 3 petals in 180 degrees. And after 180 degrees, it goes over this twice for the second time. So if you draw this for 0 through 360 degrees, it goes around this 3 petal rows twice. Okay? But since we just want the area of one petal, this is where you begin and end. You start from 0 and you end at pi over 3. Okay? And that information would have been impossible for us to know unless we knew how to draw the graph. Okay? That's why knowing how to draw the graph is important. All right, now let's actually do the computation. So the area is really integrating over this one petal, this 1 dA, right? And then dA is r d theta. And you go from, you're trying to paint this radially, right? So where does these paintbrushes begin? 0, right? And it end at here, right? So you start at 0, and you end at 5 sine 3 theta. The brushes end at that curve, right? And your angle theta goes from where to where? 0 to?
3 pi. Or pi over 3.
Pi over 3. Okay. That's what we just determined by drawing the graph. Okay? So that's what we have to integrate. Okay? So let's see. 0 to pi over 3. Now if we integrate r, this is 1/2 r squared. And by the way, you probably know this by now that whenever we're just looking for the area, the thing that you integrate is just 1/2 r squared. But if you're looking for volume, it's not this one. So don't take that as a formula or something. It's better to just do the integrals. Okay. All right. Oh, we already did the integration by r, so that's not needed. That's what we have. And then 0 to pi over 3. When this goes in there, this is 25 over 2 sine 3 theta squared, sorry. All right, we end up with sine squared again. How do we do the integral? We use this formula, right? You have to use this formula. Okay. With, instead of 3 theta, instead of a, you have 3 theta, so what happens to that? Let's pull the 25 over 2 outside the integral. Okay, so we're trying to rewrite sine squared of 3 theta using that formula. So what do we write? Formula is 1 minus cosine. No. Instead of a, you have 3 theta. So what do you write? Cosine 6 theta, because twice of 3 theta is 6 theta. Okay? And then,
Wait, don't you not need the integral sign anymore? You just
no,
Oh, you
I just
just
applied
plugged in.
this,
Okay.
this transformation, and I still need to integrate, okay? All right, so now let's pull the 1/2 out. You just want to move away the numbers so that you can worry about that later. And then if I move that away, now I just have to integrate 1 and cosine 6 theta, so let's do the integral. Integrating 1 gives you theta. Integrating cosine gives you
sign
sine, but because of this 6 in front of
1/6.
theta, you need 1/6 of sine 6 theta, and you have to plug in pi over 3 and 0. Now when you plug in pi over 3 to here, 6 times pi over 3 is 2 pi, and sine 2 pi is 0. When you plug this in here, you get sine 2 pi, that's 0. If you plug in 0, that's 0. So this doesn't give you anything. This does give you something when pi over 3 is plugged in. So let's see, what do you get? You get 25 over 4 times pi over 3. So the final answer is 25 pi over 12. That's the area of one petal. Now what if you wanted the area of the entire rows? What do you do?
multiply by 3.
Multiply by 3. Yeah. By 3. You don't want to multiply because it's the 3 petal rows. So that's how you solve these questions.